Hey everyone, welcome back. Today I've got something interesting on the bench, a safety barrier from Phoenix Contact. Now, if you work with instrumentation, you know usually the barrier supplies the power to the sensor, and that's a passive sensor. But this barrier is different. It's built for an active input. That means our sensor or field device has its own power and actually pushes the signal into the barrier. It's the opposite of the standard loop-powered setup. So let me show you exactly how to wire and test this thing properly. First step, as always, is waking this device up. We need a standard 24-volt DC supply. I'm taking my plus 24 volts and putting it right here into terminal 3. The minus 0 volts goes right next to it into terminal 4. Let's flip the switch, and there we go. You see that green LED? That's our heartbeat. It tells us the barrier is powered up and the internal electronics are running. Now for the fun part, simulating the sensor. I'm using my trusty old calibrator here. It's seen better days, but it's still dead accurate. Since this is an active input barrier, I need to configure this calibrator to source mode. It's going to generate the 4 to 20 milliamp signal just like a 4-wire transmitter would in the field. Let's hook it up. The plus from my calibrator goes to terminal 1. The minus connects to terminal 2. Basically, we are forcing the current right into the front end of this barrier. Now, what about the output side? We need to simulate a PLC or DCS card. I'm using a 250 ohm resistor across the output terminals. I do this because most industrial control systems use a 250 ohm input impedance to convert that current into a voltage they can read, usually 1 to 5 volts. By adding this resistor, we're creating a realistic load for the barrier to drive against. It's a simple trick, but it makes the test real. All right, everything is wired. Let's see if the signal actually passes through. I've got my amp clamp on the output loop to verify the values. I'm injecting 4 milliamps from the source, and looking at the clamp, we've got 4.28 milliamps. Okay, that's a little high. Honestly, I forgot to zero out my amp clamp before we started, so ignore that slight offset. The important thing is the signal's there. Let's bump it up to 12 milliamps. Boom! The output follows instantly. And finally, full scale at 20 milliamps. The barrier is tracking the input perfectly. This confirms the isolation is working and the channel is healthy. So, that is the breakdown on wiring an active input safety barrier. The main takeaway? Always check if your field device is sourcing power or needs power. That changes your wiring completely. If you want me to cover more in detail those barriers, let me know in the comments. Thanks for hanging out, and I'll see you in the next one.